Hi everyone. So in this video, I'm going to show you how to use the trigonometric ratios, sine, tan, and cos to work out an unknown length in a right angled triangle. So this is all about identifying the correct side. If we look at our first example, we need to work out the length of AB in each of these triangles. And to identify which of these ratios we need to use, we need to label the sides in respect of the angle. So we can see that the length A to C is opposite this angle. So we call this the opposite side. We know the hypotenuse is opposite the right angle. So we'll call this the hypotenuse side. And the length between the known angle and the 90-degree angle we call the adjacent. Then we can see that we want to work out A to B, and we've been given the hypotenuse B to C, so we don't need the opposite. So if we go to our ratios, we don't need the opposite, so we'll cross these out. So we're going to use the cosine ratio. So the cos of a known angle theta will be the adjacent length, which is what we're trying to find. This is A to B, divided by the hypotenuse length, which is given as 6. So to work out A to B, we need to multiply both sides by 6, because then these will cancel. So if we have 6 multiplied by the cos of 40, this will give us the length A to B. And I'll show you how we can work this out on our calculators. So we press 6, and then we want the cos button. We enter 40, and we'll close that bracket. So this gives us that A to B is 4.6 centimeters to 1 dp. Okay? If we look at the orange triangle, again, we need to label the sides in respect of this angle. Now, the A to B is now opposite the angle, so we'll call this the opposite length. The hypotenuse is opposite the right angle, and the adjacent runs along between the angle and the 90 degrees. And we need to work out the opposite, having been given the hypotenuse. So in this question, we don't need the adjacent length. So if we cross out this adjacent and this adjacent, you can see we're going to use sine. So the sine of the angle 34 degrees will be the opposite length, A to B, divided by the hypotenuse, 11. So again, we'll multiply both sides by 11 to cancel this out. So A to B will be 11 multiplied by the sine, 34 degrees. We can do this on our calculators. So 11 sine 34, and close that bracket. So A to B to 1 decimal place is approximately 6.2 centimeters. Okay, let's try some more questions. So in example 2, we need to work out the length A to B again. So if we label the sides, this is opposite the angle, the hypotenuse is opposite the right angle, and the 26 is adjacent because it runs between the angle and the 90 degrees. And if we want to work out length A to B, then we don't need the hypotenuse. So we'll cross this out, and we'll cross this out, and we're going to use tan. So the tan of 49 degrees will be the opposite length divided by the adjacent. We'll multiply both sides by 26. So we get 26 times the tan of 49 degrees. And this gives us 29.9 centimeters to 1 decimal place. Okay? So perhaps you want to try example 3. Remember to label the lengths and then to identify which ratio to use. You can pause the video and come back when you're ready. Okay, so welcome back if you had a go. So we'll label the sides. We've got the opposite, the adjacent, and the hypotenuse. If we're working outside y to z, we don't need the hypotenuse. So we'll cross this one out and this one out. So the tan of the angle 40 will be the opposite length divided by the adjacent y to z. So now because we want to work out y to z, we need to move this over to the left-hand side. So we'll multiply both sides by yz. And then these will cancel. So now we'll have y to z times the tan of 40 will be 16.8. And then we can divide both sides by the tan of 40. And these will cancel. So y to z will be 16.8 divided by the tan of 40. If we go to our calculators, we can enter the fraction 16.8 divided by the tan of 40. And we get approximately 20 centimeters. Okay? So when we have questions like this, when the unknown is on the denominator, we need to use a bit of algebra to make this the subject. Let's try example 4. In example 4, we've got a problem-solving type question where we need to work out the length of B to C. So the way we'll go about this, we need to identify the right angle triangles. If we think about A, B, D, then we can work out this length. And then if we think about A to C to D, then we can work out this length. So BC will be the big length, take away this small one. Okay? So we'll begin with this blue triangle. And we want to work out the length B to D. We know the hypotenuse is 14 and the adjacent is 8. Now we could use trigonometry to work out by finding this angle as the sum of these two. But actually it's a lot easier to use Pythagoras' theorem because we have the other two lengths. So B to D will be the square root of 14 squared minus the 8 squared. And this works out as 11.49. And then for the red triangle, we have an angle of 17 degrees, and we don't know C to D. So now we have to use trigonometry because we don't know either of the other lengths. So we want to work out the opposite side, and we have the adjacent side. So we're going to use tan. So the tan of 17 will be the opposite divided by the adjacent. If we move the 8 to the other side, we'll get 8 tan 17. And we can work this out and we get 2.45. So I'll label this on a diagram. And we know B to D is 11.49. So B to C will be the 11.49 minus the 2.45. And this gives us 9.04 centimeters. Okay? How did you get on with that? Let's try one final question. Okay, so in our final question, we need to work out the length A to B to three significant figures. So do you want to give this question a go yourself? You can pause the video and come back when you're ready. Okay, so welcome back. So the way we're going to go about this, we need to find the length B to D. And we can find this length out using the triangle BCD. So once we have this length, we can use trigonometry again to work out this length using this triangle in blue. So we'll begin with BDC. We want to work out BD, which is the opposite side, and we've been given the hypotenuse, so we're going to use sine. So the sine of 32 will be the opposite, b to d, divided by 3.1. We'll multiply both sides by 3.1, and we get b to d is 1.64. And then we can work out a to b using a blue triangle. We've got the height now, and the angle's 42. So because we have the adjacent and we want to work out the hypotenuse, we're going to use cos. So the cos of 42 would be the 1.64 divided by a to b. So a to b would be the 1.64 divided by the cos of 42. And when you work this out, we get approximately 2.07 meters to three significant figures. Okay? Well, how did you get on with that? I hope that's given you an idea on how to find lengths in right-angled triangles using sine, tan, and cos. In the next video, we're going to look at how to work out an angle using the same ratios.